Yeah, Anu, we are live now.
Excellent, thank you. Hello, everyone. Namaste and welcome to the fifth lecture as a part of the Scientists from India's Past and Present series. This series was initiated by the Indian National Young Academy of Sciences, INYAS, which is the first and only recognized Young Scientist Academy of India. INYAS was founded by the Council of the Indian National Science Academy. We started this series with the aim of showing the incredible achievements that have been made by some of our most eminent scientists in India. In this globalized world, the current and future generation of young scientists are exposed to a lot of scientific work, but at times we fail to appreciate the work done by scientists in India itself. We have been blessed to have many people with a strong scientific temper who have made important discoveries in India. This series aims to celebrate them. With that, today, for the celebratory lecture on Dr. Vikram Sarabhai, I welcome Dr. Nair, who was the ex-chairman of ISRO and is an awardee of Padma Vibhushan. We will not delay the series a lot, and the way the format is going to work is we're going to have two short lectures from INYAS members before our chief guest takes over and gives us a long lecture. So I'll introduce our first lecturer, who's Dr. Upasana Ray. She's a senior scientist and deputy head who works on infectious diseases and immunology and is a member of INYAS. She's a Sir Powell Fellow and works at the CSIR Indian Institute of Chemical Biology. Upasana, please share your screen and give the first lecture.
Namaste. So I'm going to share the screen and just let me know whenever it's visible to you. I'm going to take off my video because of internet connection, but just bear with me. So I hope you all can see the screen.
Yes, we can.
Okay. So thank you, Dr. Anup, and very good morning and namaste, every one of you. And it's a pleasure for me to get this opportunity to start the session with my short talk. Today, I'll be talking about cosmic rays and contributions of Dr. Vikram Sarabhai. First, I'll shed some light on few facts. Our Earth is protected by a strong magnetosphere, as you can see here. Cosmic rays have been categorized into two major types based on the origin, and this is a very layman's terminology I'm using for the broad audience: solar and the galactic rays. However, more commonly the term is used for the extrasolar flux. Far away in the space, when a tiny particle of matter flies like a bullet, propelled by colossal forces, propelling itself nearly at the speed of light, and suddenly, if now a planet comes in front, what will happen? This high energy particle, which is unstoppable, rips through this planet's atmosphere and collides with the atom. There are many types, destroying both the particle as well as the atom in flash of pure energy. This creates more particles and widens up into a cone of particles. The cone reaches the planet's surface, and we say that this particular planet was hit by cosmic rays. Cosmic rays are not rays actually, as it was thought many, many years ago. They are particles, they are bits of matter coming directly to us from deep space. Riddle of cosmic rays has been solved over many, many years in stages. However, we are still doing a lot of research on this. So how they are created and what kind of particles they are. Majority of the primary particles never reach us. Rather, they strike the atmosphere and unleash a torrent of secondary particles that shower down. In 1930s and 40s, scientists studied these particles and started understanding the nature of cosmic rays. Now, cosmic rays are of two major types, primary and the secondary. Primary cosmic rays are comprised of protons mainly. When there is an inelastic collision between protons of primary rays and a nucleus of oxygen or nitrogen, showers of pi mesons and some hyperons are produced. These are called as secondary cosmic rays. In this process, gamma rays are also in picture, and they distribute into electron-positron pair, and this forms a continuous process called as cascade shower. Further, it is worth mentioning that cosmic rays have two types of components, hard and soft. The primary rays or protons form the hard component, and they are immensely penetrating in nature. Also, based on the location and direction, there are different types of cosmic ray variations like latitude effect, directional effect, and altitude effect. So I won't go into much details for this. With this very basic overview of our understanding about cosmic rays, I will take few more minutes to highlight some of the contributions of Dr. Vikram Sarabhai in the field of cosmic rays. Dr. Sarabhai's initial days of career development in this field involved studying the variations of cosmic rays in the Department of Physics, Indian Institute of Science, Bangalore, during 1940 and to 1945. During this time, he used various setups of Geiger counters and had set up experimental Geiger counters as well at Kashmir Himalayas for high altitude variation studies. Today, we know that above the layer of Earth's atmosphere, as the height increases, the intensity of cosmic rays also increases. So that's the altitude effect. This photograph over here shows Dr. Sarabhai taking measurements in Kashmir, and I have taken this picture from his thesis. It's not very clear, so apologies for that. He found that for the first time, intervals larger than 1/50th of a second, there was complete time randomness of arrivals. He developed a method of shower anti-coincidence for direct measurement of slow meson intensity. He stated that possibly slow mesons are created in lower atmosphere from photons and as well as protons. Also, he found that electronic knock-on showers produced by mesons contain two particles. So if you remember, I was talking about something like this in cascade showers. So the idea was already there. After his stint at IISc Bangalore, he moved to Cambridge University, where he worked on high energy gamma rays and mechanism of photofission. He developed a method for measuring flux of gamma rays there. In 1947, he was awarded PhD degree, and his thesis, as you can see here in the snapshot, entitled Cosmic Ray Investigation in Tropical Latitudes, which is compilation of work done in India and followed up then after this period in Cambridge University. After finishing PhD, he returned India. He studied day-to-day changes of cosmic ray intensities very deeply, and his work was useful in providing snapshot of varying electromagnetic state of interplanetary space. And he has many more to his credit, but because of time, with this short introduction, I would like to stop, and my INYAS colleague, Dr. Pankaj, will take over and throw more light on his life and on his work. So thank you so much.
Thank you, Dr. Ray. The next, I would like to invite Dr. Pankaj Kumar, who holds the position of a Scientist F at the Inter-University Acceleration Center. His research focus is on radiocarbon dating and its applications in quaternary research, archaeology, and biomedical research. He is also a recipient of the Indian Physics Association Young Scientist Award. Dr. Pankaj, can you please share your screen and share your thoughts?
Yeah, can you hear me, Anu?
Loud and clear.
Thank you. Yeah, and you see my screen as well, right?
Yes, it's very clear.
Okay, good. Thank you, Pasna, for setting the tone. And I will be talking a little bit about his early days, his work, and his contribution in short, of course, because of limitation of time. Professor Sarabhai, he was born in 1919 on August 12. So after 1 week, we will be celebrating his birthday. And INYAS has put up an effort where we close to their, close to the birthday, we celebrate, the work and life of famous scientists of India's past and present. So he was born in Ahmedabad. His father his name was Ambalal Sarabhai and his mother was Sarla Devi Sarabhai. He was in fact born in a wealthy family, and they were the industrialist, and they were the owner of very first textile mills in Ahmedabad. His family was closely associated with the freedom movement of India. So his parents were freedom fighters, and his family, his house, the named as the Retreat. It was a kind of a visit place for many important people from all walks of life, and that's what later reflected in his personality. So in important people, you see this is the one of the picture where you see that young Vikram Sarabhai is sitting with his parents, and in the middle you see Rabindranath Tagore. So such a high profile people were left imprint in his life. So yeah. So then for early education, he studied in a school which was run by his family and started by his mother, Sarla Devi Sarabhai. And for intermediate, he did intermediate in science from Gujarat College, Ahmedabad. And then he went to do his tripos, his BA honors from Cambridge University upon the recommendation of Dr. Rabindranath Tagore. And you see his letter on November 1, 1935. Dr. Rabindranath Tagore wrote a letter to Cambridge University. And he, at a young age, Rabindranath Tagore saw the keen interest of Vikram Sarabhai in science and take science as a career. So where he has written that he is a young man with keen interest in science, and I am sure a course of study at Cambridge will be of immense value to him. And you know that if you look at today, that Rabindranath Tagore was not wrong at all, because he was recommending a father of India's space program. And then he did his BA honors in science from Cambridge University between 1937 to 1940. And that was the time when World War II started, and because of that, he came back to India and he worked with Sir C.V. Raman at ISC Bangalore. For 5 years, he was in ISC Bangalore, and that was the time where he worked on cosmic rays, and he wrote his first paper, which was described, which was also described by my colleague Pasnare. In 1945, he went back to Cambridge to pursue his PhD degree. And actually, this was his first paper, the time distribution of cosmic ray. And you see this paper was, I find it quite, peculiar because he is a single author in this paper. And this paper was communicated by Sir C.V. Raman. Although C.V. Raman was not author in this paper, but I mean, this is something unique if you compare it with today's world, where supervisors or the person with whom you are working, they always find a place in the paper. But somehow I think C.V. Raman gave him independence, a place to grow as an independent researcher, and a place to, so that he can think freely without any barrier. So this was his first paper, which was published in Indian Journal, which was the Proceedings of Indian Academy of Sciences. And in fact, he was an institution builder. He built many institutes. After coming back from UK after his PhD at the age of 28 or so, he started a lot of organization. I mean, first of all, he brought research into the textile industry. That was the time when there was no research in the textile industry, and he, founded an association called Ahmedabad Textile Industries Research Association in 1947. And then at the same time, at his house, he started Physical Research Laboratory, which is India's pioneer institute, and also that time called Cradle of Space Science. He started this institute from his own house. And then later he felt the need of having management education, and then he founded IIM Ahmedabad. And then Indian National Committee for Space Research, which later on became ISRO. And then many more institutes, and not only related to science, but also science communication, and then art, Darpan Academy of Performing Art, along with his wife, he founded that. And then for briefly, he was, head of India's nuclear program also after the demise of Bhabha. And then he was instrumental in bringing out a lot of institutes related to nuclear research, fast breeder test reactor, and then variable energy cyclotron center in Kolkata, and then Electronics Corporation of India Limited, ECIL, Uranium Corporation of India Limited. So he was in fact a multidimensional personality, I would say. He was interested not only in physics, but also in textile, pharmaceutical, electronics, nuclear power. He was a dreamer. The objective of his life, once he mentioned that objective of his life is to make life a dream and to turn that dream into reality. So he was such kind of a genius and multidimensional person. He was visionary, founded a lot of institutions which are, in a way, he was the founder or instrumental in making new India with infused with science. And he was a leader, teacher, inspirer. And Dr. Kalam also mentioned once that I was spotted as a young scientist by Dr. Vikram Sarabhai. So he used to recognize the person at an early age. As I said, that he founded Management Institute, IIM, so he was management educator, music and art lover, and entrepreneur of social change. And then I would end my brief talk with some of his quotes, where he said that choosing to lead one kind of life means putting aside desire to pursue other options. So he was the one who was interested not only in astro, physics and space sciences, but also in music, in art. And then when he started and he postulated to start space activities in India, and that was the time when we were not a very rich nation. So it was being criticized a lot here and there. So to answer them, he said that there are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations like US and USSR at that time in the exploration of the moon or planet on manned space flight. But we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of space technology, such advanced technology, to the real problem of man and society. So he wanted to utilize this, the knowledge of the space science to the benefit of the common man. India awarded him with two of the big civilian honor, with Padam Bhushan in 1966 and with Padam Vibhushan after his death in 1972. And these are some of the pictures when Dr. Kalam and then Vikram Sarabhai are discussing something. And this is the picture where his wife Mridani Sarabhai received the award received the Padam Vibhushan award on his behalf. I will stop it here, Anup, and then thank you very much. And I hope that you will listen. We will all listen more and personal from the personal account of Dr. G. Madhavan. Thank you very much. Anup, you are muted. You have to unmute.
Sorry. Thank you, Pankaj. Thank you for the quick overview. And with this, I will invite Dr. Chandrasekhar, who is the and heads the Carbon Laboratory at the IIT Hyderabad. He has won a number of awards, so I can't go through all of those, and has plenty of recognitions to his name. But the latest feather in his cap is the Swarna Jayanti Fellowship. So congratulations, Chandra, and I welcome you to please give an introduction to Dr. Nair.
Thank you, Anup. Of course, it's a really privilege for us to have Dr. Nair with us on this platform. Of course, he doesn't need any introduction for a scientific community, but for the sake of general viewers on our YouTube channel, it is my pleasure to formally introduce Dr. Nair. So Dr. G. Madhavan Nair started his career in Tumba Equatorial Rocket Launching Station in 1967. Since then, he has held various positions, posting illustrious milestones on his way. He rose to the position of Director, Vikram Sarabhai Space Center in 1999, and finally to the position of Chairman ISRO in 2003. During his tenure of 6 years as Chairman ISRO and Secretary Department of Space, 25 successful missions were accomplished. While working as Head Payload Integration Section at TERLS in 1967, Dr. Nair was chosen by Dr. Vikram Sarabhai for hands-on training on the integration and launch of rockets at CNES, France. On return, he has been one of the key persons of the pioneering SLB-3 project team, in charge of the electronic integration and check out the vehicle, where he worked in close association with stalwarts like late Dr. Kalam and Dr. Srinivasan. Later as Project Director, PSLV, and Program Director, Integrated Launch Vehicle Program, Dr. Nair played a decisive role in the development of Polar Satellite Launch Vehicle, PSLV, and Geosynchronous Satellite Launch Vehicle, GSLV. In 1995, he became the Director of Liquid Propulsion System Center of ISRO, where he significantly contributed to the development of indigenous cryostats. In September 1999, Dr. Madhavan Nair became the Director of Vikram Sarabhai Space Center, the lead center of ISRO for launch vehicle development, and continued in that post till 2003, when he was chosen to become the Chairman of ISRO and Secretary, Department of Space, and Chairman, Space Commission. During his tenure as Chairman, he has taken several initiatives towards development of futuristic technologies to enhance the space systems capabilities, as well as to reduce the cost of access to space. The application programs such as teleeducation and telemedicine developed by ISRO could meet the needs of the society at large. The Village Resource Center, established through satellite connectivity, which enabled the farmers to get information on important aspects like land use, land cover, soil and groundwater prospects, farming system, action plans based on weather, community-specific advice on soil and water conservation, was yet another move to improve the quality of life of the people in the rural areas. As Chairman of Space Commission, Dr. Nair has been responsible for checking out the future plan for space research in the country. In the international arena, Dr. Nair has led the Indian delegation for bilateral cooperations and negotiations with many space agencies and countries like France, Russia, Brazil, Israel, etc. He has also been instrumental in working out mutually beneficial international cooperative agreements. Dr. Nair has led the Indian delegation to the Science and Technology Subcommittee of United Nations Committee on Peaceful Uses of Outer Space. Born on October 31st, 1943 at Thiruvananthapuram in Kerala, Dr. Nair graduated in engineering from Kerala University in 1966 and underwent training at BARC Bombay. He was conferred doctoral degrees by several universities and reputed institutions in India. Dr. Nair is a fellow of Indian National Academy of Engineering, Astronautical Society of India, National Academy of Sciences India, Indian Society for Non-Destructing Testing, and Aeronautical Society of India, and member of the System Society of India. The nation honored him with the Padma Vibhushan in 2009 and Padma Bhushan in 1998. Dr. Madhavan Nair has several other awards and honors to his credit. With this, I request Dr. Nair to continue his today's lecture.
Thank you, Dr. Sharma, for the nice words of introduction. Dr. Anu Mahajan, Dr. Upasana Roy, Dr. Pankaj Baghel, other members of the INYAS, and the participants in the seminar. For all of you, my wishes, warm wishes on this occasion. Especially this week is coinciding with the birth anniversary of our great scientific leader in the country, Dr. Vikram Sarabhai. I'm really honored to be invited to talk about my association with him and how he has taken his dream, how we have taken his dream to its fulfillment over the last 3-4 decades. Well, I think it was a very nice introduction by Dr. Pankaj on the life history of Dr. Sarabhai. So I don't have to labor much on it. And Dr. Upasan also has given a very nice starting with respect to the cosmic ray research on which he started his scientific career. Well, I think when we look back, a person who is coming from industrialist family with a lot of wealth and nothing much to worry about the future, he has taken passion to physics and then continued his study on the physics. And from the Cambridge, he got a degree. And later, under our great C.V. Raman, Dr. C.V. Raman, he did his research work. And you have seen how he has awarded the research PhD. And see, that shows that he was really passionate towards pursuing science. And cosmic rays always has been a worry for the human race. Of course, it is on the outer stars and sun and so on. A lot of radiation falls on the earth. And how it affects the people. That was his concern to start with. As part of that, I remember he has come to Thiruvananthapuram and set up a small laboratory here as part of the Meteorological Department Observatory. And perhaps that was the first visit to Trivandrum and starting point of his association with Kerala. Of course, finally it culminated in his marrying Dr. Mrinalini Sarabhai, a Keralite, and also the entire space activity has been nucleated at a village near Thiruvananthapuram called Veli village. And that shows that how he was attached to Kerala all these years, though he is hailing from Gujarat. Yes, I think I must remember the first meeting with him. It was in 1967 when I joined Tumba. Dr. Kalam was my immediate boss. And of course, Dr. Sarabhai used to come to Tumba almost every month. So in one of those days, we were all invited for lunch and we joined with him. And, we were all expecting a very stiff personality with a serious face and suit and perhaps a pipe on his mouth and so on. But when I saw him, I was really astonished. There was an ordinary man in pajama kurta wearing beach chappals and walking to us. Well, that showed his simplicity. He never believed in the ornamental dressing or show off and things like that. He was always living down to earth along with the people of the country. He entered the dining hall and immediately, without even turning to us, he shouted at Chelapan, he was a cook there, "Oh, what have you made for me?" So he explained how he has made a Kerala dishes, purely vegetarian dishes for him. And he said, "Oh, well done." Then only he turned to us. Of course, all of us were introduced. And since I was from the bar training school, I didn't have to toil much to explain my background. And after listening to all these things, young man, you have selected the right area. Space is full of challenge. Keep your eyes and ears open. That will take you to the great heights. This was the first words I heard from his mouth. Still, it resounds in my mind, and it has guided me all through my career. Of course, you all know about how Tumbaketu rocket Rajya station came to existence. He had a tremendous contact with the scientists abroad in USA, Russia, and Europe. In spite of the Cold War, he had a close relation with all these people. And the net result was to set up an international sounding rocket launching station at Tumba. Of course, mainly to explore the electrojet studies over the equatorial region. And this turned to be an ideal location, and we started work there. And first, 1963 itself, we made a rocket launching from this Tumba Equatorial Rocket Station. And it was a very simple experiment to study the, what you call a charged particle winds in the ionosphere. It was a great success. But while all this was going on, he has had a great vision. He has declared to us that, as quoted earlier, we should be second to none as far as mastering this high technology and using the high technology for the benefit of the common man. Well, rocketry, we had a beginning about 300 years back by Tipu Sultan. He was the first in the world to use a rocket as a weapon against the British. But afterwards, it was all in cold storage. It is Dr. Sarabhai who has rekindled the old aspirations of the rocket scientists. And he set the goal, and he set competitive teams, maybe 3 or 4 teams, to parallelly work on the development of the rocket motors. Of course, he always encouraged the healthy competition among the scientists, and so that the best in that comes out. And that was the starting point of his the initiation of the rocket program here. We were just toying with small rockets, which can hardly go to 10 kilometers and carry about 10 kilograms into that height. But at the time itself, he said, no, this is not sufficient. You should make a satellite which can take Indian satellite launch vehicle, which can take an Indian satellite to an orbit of nearly 400 kilometer high. It was really an ambitious target. We didn't know the ABC of rocket, the propellants technology, control or guidance or whatever it is, but still he set the goal such high. Again, in that, he has introduced a competitive way of bringing out the best design. He has made about 12 design teams for various aspects, like, the solid rockets, the liquid engines, control systems, electronics modules, and of course, Professor Rao, one of his favorite students, he was put in charge of developing the satellite technology. And surprisingly, perhaps I was junior most in the lot, just hardly 2 years into the stream. And he picked me as a leader for developing a telecommand system. He never believed in the hierarchical system of grades or the position, etc. But he always believed that given an opportunity, the people can do. So that faith, what he has put in me, is something which has encouraged me to further continue the adventurous journey in space. Well, I think we have completed all those preliminary designs. Then the question came, how to go about the next step. We cannot have all the designs going parallelly. So he again had extensive reviews. And at the end of the review, out of the a dozen combinations, the third combination was selected. That's how the name SLV3 came into existence. Of course, there again, he cut across a hierarchy. He selected Dr. Kalam to be the leader of that project. Earlier, Dr. Bagley has shown one picture. There was a Dr. Sarabhai, young Kalam, and behind him, I was also there. So that is a fond memory of where we all began. Dr. Kalam, he had a very unique management style, virtually a copy of what Dr. Sarabhai believed. He believed in the strength of people and encouraged them to put their best foot forward. There is nothing in the world we cannot achieve. So that is the type of philosophy Dr. Kalam also followed. And certainly that has led to development of the first SLV3 launch. Dr. Sarabhai did not live to see that. On 30th of December 1971, he departed us from his favorite location. There's a palace hotel at Kovalam Beach that used to be his abode whenever he comes to Trivandrum. And late in the night, he went to sleep. And next morning, the boy went to wake him up. But unfortunately, he was not responsive. That is the end of that era. So our association with him for about, I would say about 8 to 10 years in space. But the type of message what he has given to us, the type of vision he has given to us, that is what is driving the ISRO space program even today. That's really a tribute to this great national visionary scientist. We all call him the father of Indian space program. And certainly we all try to live up to his expectation. In those days itself, he has seen the advantage of connectivity. You know, in one of the discussions at Ahmedabad, we were all there. He said there were only hardly hardware telephone lines. And there was a computer in the PRL. So he said this computer benefit should go to the villages. He called one of his colleagues and said, why don't you connect it through the telephone lines to the villages? Well, that was in some 69. And, you know, it took almost another 20 years before the internet and all came into existence. So that's the kind of foresight he had. Again, he saw the advantage of the global vision from space of the planet Earth. That gives a lot of things, a lot of opportunities. The first and foremost is from a satellite in the geostationary orbit, you can reach out to almost 1/3 of the globe. Of course, India is a very vast country with 3,000 kilometers across, and to reach every remote village, the satellite communication is the only solution. Again, looking from the space, you get a synoptic picture of the resources on the ground, sea, forest, and so on. So this data can be widely used to change the quality of life of the people. So these two areas, he has really given the thrust. Before his demise itself, he had made an arrangement with the NASA to bring a satellite over India, ATS-6, if I correctly, that was positioned right over the central India. It was providing connectivity to the Madhya Pradesh, Maharashtra, and part of Gujarat, and so on. About 2,000 villages were selected in that. And using the satellite, he has envisioned that we should provide the television connectivity. Television has come to the country only in 81. Well before that, he said that this technology is something which is useful. Yes, it's turned out to be so. Those days itself, what he has demonstrated, using the satellite and using the teams on the ground. It is not very sophisticated production companies. He assembled a village artisans and the dancers and artists and so on. So he made local programs, mainly targeting for education purposes. That is, adult education was one aspect of it. Then how to have good hygienic living, how to have good agricultural practices, and how to follow good social norms. So that was a theme. And all the programs were tuned in a local language with a local themes. You know, there are a lot of folk dance and so on, which is happening there. And that themes he has conceived. Yes, later, it was in 1974, we could make it happen. And even the United Nations acclaimed it as one of the finest experiments in sociology using space technology. Well, that shows you know, how he was looking into the future. Then, of course, communication, NASA connection was there, but still he said that the 10-year profile what he has given us, it included development of satellite for Earth observation, the communication purposes, and its application. So that document, which have the 10-year profile, was taken as a Bible by all of us. Professor Rao and his team, they went on developing the satellites. They made the Aryabhata, the first satellite to orbit, and then afterwards the Bhaskara. Aryabhata satellite was mostly for science, X-rays, gamma rays, and so on. But Bhaskara had a camera on board. And with that, we started pictures of the Earth. But still, you know, we are not reached, those pictures were very quiet. We can get a resolution of nearly 1 kilometer only. Then to go to fine resolution, we started developing the IRS series of satellites. Those satellites had a very fine resolution, telescopic cameras and high precision sensors. But unfortunately, we did not have capacity to launch from here. So we took the Russian support, and the Russian launch vehicles were used for this purpose. Similarly, for the communication purposes, I think ISRO had sent a team to USA to work with one of the industries to design and develop inside one series of satellite. And we were the only country to start with a 3-in-1 platform that is used for TV broadcasting, telephone connectivity, and weather monitoring. All 3 functions are combined into one, which other countries do separately. So we have demonstrated first time such a complex thing is possible. Of course, the first 2 launches took place, but they didn't live up to our expectation. After about 6 to 8 months, they all got into some problem. But later, that failures were analyzed, and the satellites were made there. Then subsequently, it was launched from French Guiana. So we had a good series of inside one series of satellite. In fact, third and fourth satellite lived up to almost 10 years. Subsequently, we have the INSAT series of applications, which, of course, first it was connecting the metros for the telephone, replacing the telephone cables. Then TV broadcasting, first time, nearly 1,000 stations in the villages in the country are provided with relay stations through the satellite. Again, about the audio, All India Radio has benefited. Every one of the station is connected to the satellite. So the satellite series have really served the purpose. And later, when we had the IRS series of satellites, we had a final resolution picture. Today, we are at something like a sub-meter class, something like 0.2 to 0.3 meter object we can detect on the ground. So this is used very widely for monitoring the agriculture, if there is any disease or pest attack, and have proper information, predicting the yield of the various crops, and then intervening for the procurement and distribution and so on. And more than that, the floods and other natural calamities, when they take place, we are able to identify the inundated region instantaneously and rush relief to such regions. Either when the snow melt in the Himalayas or the forest fire, all these are being monitored. Above all, it has come handy for fishermen to identify the locations where maximum fish catch can be there. And that program also has been utilized. So if you see all these aspects, this technology has been put to use to benefit the common people. Though we spend a lot of money and efforts in this, but ultimately the benefit goes to the people. Then we were depending on the foreign launchers, and the SLV-3 was a great success, but hardly it can carry about 40 kilograms. Whereas IRS series of satellites are around 600 kilograms and above, and the INSAT series was about 2 tons. So that is how we started the design and development of PSLV. And PSLV today has turned out to be the most reliable and least cost solution for launching to space. We call it the workhorse launcher of India. That again, it was a very arduous journey. We had to learn ABC of the liquid propulsion technology, large solid booster compared to the 10-ton solid booster what we made for SLV-3. Here there was a 125-ton solid booster to be developed. Similarly, the liquid engines were used for the first time. More important, the control and guidance system, which can ensure the spacecraft is taken to the right location very precisely and left into a precise orbit. So this again was almost 10 years of hard work by more than 3,000 workers, 3,000 team members within ISRO, and almost about 10,000 people from the industries, about 1,000 people from the academics and so on. We brought in a collaboration with the industry, academic institutions, and research institutions to see that our space program achieves great heights. So this also is a theme which has been set by Dr. Sarabhai. We wanted to see that the technology what we develop should penetrate to the industries so that they can benefit and bring out the high quality products. So certainly we have succeeded in that. Later, of course, when we wanted to have the GSLV, a cryogenic stage was a must. We signed a contract with the Russians. It was going well, but due to when the Russian Republic broke up, there was a lot of pressures from US and the technology transfer was stopped. So they have supplied only a few stages which are ready to fly. Using those stages, we have taken the 2-ton class of communication satellites to orbit. Then, of course, parallelly, we had to mount the effort of the cryogenic engine development in the country. It was the most complex rocket engine we can think of. It has got all kinds of material-related problems, thermal problems, structural problems, and so on. And handling gaseous and liquid fuel like hydrogen and oxygen. So this was a very, very complex issue. But still, our teams deciphered this. And the first indigenous cryogenic engine was realized somewhere in 2008. And since then, we didn't live with that low thrust engine which Russia has given to us. We went on to make the new generation engine with about 20 tons of thrust. So that turned out to be a boon. And recently, what we have launched, the GSLV Mark III, makes use of this cryogenic engine. So you can see on one side, satellite development was going on. Other side, the satellite launcher development was going on. Then application technology was being developed. And all these were done in unison. The theme of a 10-year profile set by Dr. Sarabhai, we all continued. Every chairman, Professor Dhawan, Professor Rao, Dr. Kasturangan, myself, all of us followed that philosophy. We set long-term goals and see that we make sure that all these programs are implemented in a time-bound manner. In a government setup, to carry out all this is a Himalayan Herculean task. But still, the type of the organizational structure what is given to us. The Space Commission being the highest authority for this, and then the centers having total delegation of powers, and research and development is allowed to be carried out with a free hand. So all these things have worked. In a multidisciplinary environment, the cooperation and collaboration is the most important aspect. Dr. Sarabhai ensured that. See, today, in many of our scientific institutions, we are not able to achieve success or excellence, mainly because most of the scientists, they want to live in a cage. Say, Dr. Sarabhai himself used to call it as a zoo culture. So he has broken that. He has let all the wild elements free in the forest and have their way. So that is how we really groomed. Certainly that philosophy is adaptable for every field in the country. This is something we should be following him. So it's just, though he lived hardly 50 years in there, he has made a big footprint, which will never vanish. And more than that, his style of functioning, his organizational setup, organizational skills, and the vision, above all the vision, that is driving us. Of course, by about 2003, when I took over as chairman, I had an interim review of his dream vis-a-vis what we have achieved. I'm really happy to say that we have 100% fulfilled his dreams. Then the question came, what next? Of course, in the beginning of the space program, he said, we have no ambition to compete with the developed countries in sending the man to the moon or the Mars and so on. But we have broken that. We have now started a human spaceflight program by which we will be having our own capsule, which will carry 3 astronauts to space. Maybe the next step will be from Earth space to moon or the Mars. So that's the kind of goals which we are setting and going ahead. So it's again in a form of evolution. Every 10 years, nothing is static. Things get evolved depending on the needs as well as the technology. And to a great extent, we had to be self-reliant because these technologies are not available for love or money from anybody. So we had to work ourselves to achieve this thing. So that self-reliance, the lessons what he has taught us, is really unique. You are seeing the Giger tube being made in the Raman laboratories, the picture. So the same culture. when he comes here, all of us will be keen to do something new with our own hands and demonstrate to him. So that used to attract him, and he used to encourage people. And there were occasions on which things are blasted in front of him, rocket motors are blasted. We didn't show any discussion or anything. Kalam was the project leader at the time. He patted his back and said, young man, don't worry. When you do new things, the failures do come. But learn from the failures and make sure it's not repeated. Certainly, yes, we are really following that. And that's one of the reasons the ISRO has emerged as one of the top ranking organizations in the country. Thank you.
Thank you, Dr. Nair. That was very insightful and so nice to hear about your own experience and how Dr. Sarabhai has impacted not just the scientific world during his own time, but even after that. I invite Dr. Chandra to ask a few questions and I have a discussion with Dr. Nair.
Yeah, thanks a lot, Nair, for such a wonderful reflection on the life and legacy of Dr. Sarabhai. I just have a couple of questions. One is, something, because you have worked with him so closely and you have been associated with him. What do you think, and you yourself have led the organization like ISRO, which is considered as a symbol of excellence in India. So what do you think that Dr. Sarabhai has the biggest impact on the ISRO and ISRO scientists, in your opinion?
Well, the basic thing is his long-term vision. When things are happening around, he will see what needs to be done 10 years from now. So that is the starting point. Then he believed the strength of people. He used to allow them to perform freely. And even when the mistakes comes, he won't blame them. Next comes the collaborative work. You know, in a modern world, an individual can do practically nothing. It has to be a team. So the team building among the high intellectuals is a very important lesson what we have learned from him. And the style, how to bring them together, how to bring the openness in the technical reviews and so on. So that is something which then, of course, his management style, maybe because of the industrial background and the IIM and so on, he developed a unique style of what is called a matrix management. You have an institution where specialists will be there, whereas ultimately a goal has to be achieved. So tying up this each institution for the towards the final goal and focusing their energy, we call it as a matrix management system. I don't think many management books talks about it. In all the foreign management structure, it is a profit and money. So here it is not so. It is a technology challenge and the ultimate pride one gets out of it. So these are some of the lessons which I've learned. And he put people in the front first, then only anything else.
Thank you, Dr. Nair. I think these all lessons are very relevant in today's time also. So one last question from my side, as it's a really honor to have you. And you have led so many committees, so many institutes. What is your own message to the Indian young scientists in the present context, especially in terms of scientific leadership?
First and foremost is the courage and boldness. You know, we can do that. The belief should be there in their mind. There is no point in going through a beaten track. That can be taken as a pointers, but they should be innovative. They should be looking around and see the problems of the society at large and how the knowledge can be improved from where we have left. Quite often in many of our institutions, it is a copycat type of situation is happening. That should stop. We should be on our own. We should innovate. That is how the developed countries have come to the forefront of industrialization. So it's high time India also goes in that mode. Of course, in this government support is very much required because the private industry has not come forward to invest heavily in this area. But still the government support is available, but there are limitations. But if it has to multiply many times, it is absolutely essential the private and institutions, they have a partnership. The industries should come forward to put off their requirements, not only for today, maybe 5 years from now. The research and development should go towards meeting such requirements. As our Prime Minister always used to say, that the science should not be confined within the laboratory walls. It should be taken to the society. So if every one of us take that as a goal, things will be different. Of course, there are some fundamental areas of research, like what Newton has found onwards up to Einstein. They're all path-breaking inventions. So if some of our people come forward and do that, it's wonderful. But more than that, have a strong foundation in science and research capability and apply it to solve the problems of day-to-day man.
Thank you. Thanks a lot, Dr. Nair. Over to you, Anup.
Thank you so much. I'll just give a very quick vote of thanks to end the session, since we are coming to the end of our scheduled time period. So first and foremost, I thank Dr. Nair for agreeing to share his experience of working with Dr. Sarabhai. It is a great honor for INYAS to have someone of your caliber to come and talk to the next generation of scientists. We are lucky to have heard about Dr. Sarabhai from someone who has worked with him directly, and also hear about the huge achievements that he initiated and have been made through institutions like ISRO that you led. It's not very often that we hear about these small but important achievements from someone who's actually been involved in them. Second, I thank Dr. Upasana and Dr. Pankaj for sharing some insights on the work of Dr. Sarabhai. It's encouraging to see how the younger generation is also not just remembering, but also appreciating the work of some of our great scientists and keeping the history alive, which is very important if we want to have a bright future. A big thank you to Dr. Sharma, who's always encouraging as the chair of INYAS. We're lucky to have someone so supportive. Thank you to Madhvi for the technical aspects. And finally, thank you to all of you listeners. We hope you are enjoying this series and learning about some of the great scientists from India. We want to hear about, if you want to hear about any particular scientists, please write to us. INYAS is very active in organizing these series, and we would be more than happy to organize a series on any particular scientist that you want to hear about. With that, thank you, Dr. Nair, and namaste.
Thank you, Dr. Nair.
Madhvi,